Okay, part two. So I'm blocking the answers here. So pause it and try this question by yourself, please. Okay, so from part one slide, we are dealing with this. So asking symmetry with what? So if you look at it, it's this style. So left top corner, this graph, you can symmetry flip over y-axis. It's gonna look like something like this. Then it's gonna reflect it to here. Then it's gonna match. So it is symmetric over origin. Okay. So symmetric with respect to origin. How do you show algebraically? Well, this is how you show. Replace x with minus x, replace y with minus y. It should be exactly the same equation. So let's try it. Y equal to minus x cubic, that is the original equation. So replace that with a parenthesis, replace that with a parenthesis. Wherever x appears, replace it with a parenthesis. Wherever y appears, replace with a parenthesis. Instead of y, you're going to replace with minus y. Instead of x, you're going to replace with minus x. So minus y is minus y, minus parenthesis cubic means you're going to multiply by that itself 3 times. So minus times minus times minus 3 times will be minus. X cubic is x cubic. Now I have minus times minus, which is positive. So minus y equal to positive x cubic. So compared to the original, if you look at the y doesn't have x in front of it. So why don't I multiply by minus on both sides to move this minus? So multiply by minus 1, multiply by minus on both sides. Y equal to minus x cubic. Look at this. Very original. The equation afterward, they're exactly the same. That's how you show reflection over origin algebraically. So I already talked about this. Symmetric over y-axis is even function. Symmetric over origin is odd function. So we have a name for it. So I told you this is how you show algebraically. For even function, replace x with minus x. So algebraic test for even function is you replace x with minus x, and they should be exactly the same. So another way to test that is you try f of minus x, show that is equal to f of x, which is original. Then that's how you do algebraic test showing even function. Other function. So here I told you you can replace x with minus x. You can replace y with minus y. Still become the same equation. It's exactly the same thing. Another way of algebraic test for this is you do f of minus x. That is becoming minus f of x, which is changing sign of original. You do need to know this. So whenever I ask you show a function is even function or other function by algebraic test, this is the method you have to follow. So analyze a graph of the following, determine even, odd, neither. So given a graph, very simple. So is it symmetric over y-axis? Is it symmetric over origin? So upper right corner, this portion, can I reflect it and reflect over axis? Is there a matching thing? No, there's nothing symmetry about origin. So this is neither. Answer should be neither. Confirm algebraically. Okay, this is a part you need to do this. What do you need to do? You have to do f of minus x. So f of x here, you got f of x equal to x squared minus 4x plus 4. F of x equal to x squared minus 4x plus 4. That is given. How do we show even, odd, or neither? You have to do f of minus x. This is how I want to set up. Before you do anything, just set it up with a parenthesis. Anywhere x appears, just set it up with a parenthesis like this. Then you have to do minus x, f of minus x. So you plug it in minus x instead of x. Minus parenthesis square is going to be positive. It's because x is squared. Minus minus becomes a positive. So this is f of minus x. What are we doing? We are checking, is that equal to f of x? F of x is this. So I'm asking, is that exactly same as original? No, it's not. First term is the same, but if you look at the second term, they are not same. So it's not. I'm also checking, is that equal to minus f of x? That's the function here. If f of minus x equal to minus f of x means you're doing minus on original. So change sign. This change to minus, this change to positive, this change to plus. So minus f of x minus f of x. F of x is x squared minus 4x plus 4. So when you distribute this, it will be minus x squared plus 4x minus 4. So it's exactly the same as f of x, but you change the sign, plus to minus, minus to plus, plus to minus. I am checking, is f of minus x equal to minus f of x? They are not. They are not. You can check that easily here. They should have a different sign. It's not. They have same sign, busted right there. So no, it's not. So it's not even, it's not odd, neither. Okay, you try this. Pause it, try it, please. Okay, by looking at the graph, very simple. It is symmetric over y-axis. So symmetry over y-axis means symmetry over y-axis means even. So it is even. Confirm algebraically. Confirm algebraically. What are we supposed to do? You have to do f of minus x. So same thing. You start with f of x. F of x equal to x squared minus 4. What are we doing? You have to do f of minus x. So set it up with a parenthesis first. You have to do f of minus x. Minus parenthesis square disappears. It should be x squared minus 4. I am asking, is that equal to, you're checking, is that equal to f of x? Is that equal to f of x? F of x is original. Is that equal to original? Yes, they are exactly the same. So yes, it is even. Okay, pause it. Please try. Graph the function f of x equal to following using graphing calculator. Analyze the graph. Okay, look at it. Is that symmetric over y-axis? No. Even function is gone, busted. The right top corner, this portion and that portion, can you reflect and match here? It's not matching here. It's not odd either. What does that mean? Neither. This is neither. Okay, algebraically, how do we check algebraically? Right here. So f of x equal to x cubic minus 3x squared minus x plus 3. What are we doing? You are doing f of minus x. Again, please set it up with a parenthesis everywhere. First, set up with a parenthesis. We are doing f of minus x. F of minus x. So fill it in with a minus x on every parenthesis. Evaluate it. Minus parenthesis cubic. So minus times minus times minus 3 times. Minus will survive. Okay, minus parenthesis square, that will be positive. You got x squared. Minus minus is positive. So if you look at it, minus 3 times positive x squared, that will be minus. What are we doing? We are comparing, is that equal to original, which is f of x? Is that equal to original? Busted right here. They're not. It's not even. Then you're checking, is that equal to opposite sign of the f of x? So then you're saying, is that equal to minus f of x? Minus f of x means change sign. Change sign? Yes. Change sign? It's not. So it's busted. Neither. Pause it, you try. Pause it, try please. Okay, so given graphing, very simple, it's a symmetry over y-axis, so you should know it's even function. Confirm algebraically. So how are you gonna check the algebraically? So if you think about it, f of x equal to x fourth minus 8. F of, you will have to plug it in minus x. Minus parenthesis fourth power. You're multiplying minus 4 times. It will cancel out. It's gonna be positive. Even power, it will come out positive. Odd power, it will come out minus will survive. So if you look at this, it's exactly same as original. It's exactly same as original. Yes, this is even function. Okay, I have shortcut. So far I showed you multiple examples how to tell even, odd, neither, but confirm algebraically. There's no easier way. Confirm algebraically, you have to do this. The shortcut I'm going to share, what if there was no graph available? Given this, can you tell whether it's odd, even, or neither without graph, without doing algebraically? There is a very simple way to do it. So you look at the power of x. Power of x. Power of x is 4. 4. Even power, odd power. Even power. Okay, now let's look at minus 8. What's the power of x? Some of you might say, what do you mean there is no x? Minus 8, there is no x. So minus 8 is exactly same as minus 8 x to the 0 power. X to the 0 power means 1. So constant is same as x to the 0 power. So all I'm trying to say is power of x is 0, power of x is 4. Both 0 and 4 are even. 0 is considered even. So all the power of x are even, then it is even function. Let me go back to the previous examples. So what if there was no graph here? And let's say you just need to answer even, odd, or neither. Look at the power of x. 3, odd power. Power of x. 2, even power. Okay, it should be all odd powers or all even powers. If you have odd power and even power at the same time, busted. That's neither. Neither. Let's take a look at the previous example. So what if there was no graph? Again, power of x is 2, even power. Power of x for minus 4, there's no x. That means 0 power. 0 power, second power, all even power for x. What does that mean? Even function. Okay? So that's a very fast, handy way of saying even or odd. Power of x, 2, even power. Power of x. X doesn't have a power. What does that mean? First power. X means actually first power. 1 is odd power. Even power, odd power, busted already. Neither. So that's another shortcut. Without graphing a variable, you can do that. Okay, so you should log into the Alex and finish Alex homework 1.2.